Good day, everybody. Hi. Please keep carrying on coming in. It doesn't disturb me. I am Vanessa Formicola. My pronouns are she and her. And today I'll be talking about TDD and other drugs, or in other ways, all the ways in which we tell ourselves stories that we could solve quality, with a magic pill. So I'll just give you a short summary of what I'll be discussing. Some people prefer it to have an idea of what the talk will entail. So first, I'll give you a little bit of background. I'll give you a little bit of background about my past experiences and the key issues I've encountered in the different contexts so that you can understand where some of these thoughts come from. And then I'll open the topic of holistic quality and I'll dive into that. And then I'll draw some conclusions. I'll try my best to leave time at the end for questions and also to let you go to lunch as soon as I can. So this is a little bit about my background, quite conventional background. Went to a computer science high school, a bachelor degree in engineering and a master's degree in software engineering. And then I started a conventional path of a software engineer. So I first work as a junior software engineer and read business information, progressed to work at Microsoft, ThoughtWorks, over 2 offices, 3 countries, 11 different clients. And I work for the lovely Flo, whose mission is to improve the health and well-being of women and girls all over the world. And over all these journeys, I worked on quite a few different contexts. And, some of you have had similar experiences, so you can relate. And, for example, I worked on whether it was fintech, retail, whether it was government, whether it was health tech. And for each of these different jobs, I worked on different tech stacks. And different tech stacks, I then developed my full stacks development skills. I progressed to do more architecture, more cloud design, legacy modernization, CI/CD, and in general, I used to do both consulting and software delivery. That means that I used to go and actually assess and help different clients to understand how their quality systems, their architecture, their relationships, everything worked, and help them grow in that context. So you might be wondering, why is this relevant? The reason why this is relevant to me, at least, is what I found in my journeys, and again, quite a few different contexts, is that even if the situation was completely different, the company was completely different, even a country could have been completely different, they had similar problems. And the patterns start building up, in my experience, over and over time. And these are just some of the things that I have identified. And for example, insufficient testing, I would say it's almost a constant. So enough testing to be able to confidently make any change in your system is almost, I have almost never encountered it. Low quality tests means that the quality of the individual tests wasn't very good. Again, it's something very, very common. Unclear test definitions, so this makes me laugh every time. For every team, there's a different definition of test, even in the same company, in my experience, and different teams will call, even different team members in the same team will call maybe the same type of tests with the same name, even if there are different types of tests. And in general, a disengaged attitude towards testing. So, and I could, go on this. But what I've found most of all is that usually there are 2 categories of software engineer. There's usually the one, and clearly this is a gross generalization. There are the ones who absolutely love their testing, so they couldn't possibly work without it. They pet it, they cure it, they take as much care of their test code as they would do to their production code. And then there are those who, I wouldn't say that hate it, it's more like a bored hostility. It's a sense of, I kind of have to do it. I'm not quite sure if, all of this is necessary. Maybe I do a bit more, maybe I do a bit less. It's that sense of, lack of excitement, lack of interest, not a sense of accomplishment when doing it. And unfortunately, I do fall under the, little bit addicted category of I couldn't possibly work without tests. So, but most of all, the thing I've encountered is confusion. So it feels like in such a mature space, a software engineer with such a big variety, people still ask themselves, should I test this? Why? When? How? And I think this doesn't help the categorization I was saying before, right? So if it's something that, for whatever reason, hasn't been particularly important in your context, the lack of group, kind of collective information might have an impact on it. So in general, on this, the question that lingers in the air when I'm having conversations with people is, why would I care? Right? So, why would, any of you be sitting here listening to me? Why would anyone else be listening to me when, I speak to teams and help them out? So for me, usually these are the two key things that at the end of the day, everybody bubbles down to. So we want the code to do what we expect it to do. Otherwise, we wouldn't be writing it, right? Everybody expects their product to do what, you've invested time and effort and money to do. And then you want your changes to be cheap and quick. So you want to make sure that whatever change you need to do, and this is, sustainability of your software system, that doesn't take ages and it doesn't take, lots of people hours. So then the question here usually is, then what we do? So, this is very trivial. We'll deep dive more into some techniques. But at the end of the day, this feels like one of those elephant in the room conversations. So what would you do for your code to work as expected? In general, in my experience, the only thing has ever worked to be able to the features that you want to work is to have automated tests around it. I have never seen anything else, not the best developers, not the most amount of time to make sure the feature is best. The only thing I've seen go over the test of time is actually having correct automation around the features. So anything you would want to work should have tests, in my opinion. And then what should I do to keep, my delivery cheap and quick? You need to maintain high quality code base. And that doesn't mean only clearly, tests. It means high quality tests. It means your software design overall is how as good as your code base is, as quick you will be able to make changes. So then the next question usually is, who's responsible for this? And clearly, most, teams would say, it's the team's responsibility. And that's absolutely true. So clearly, the product manager wants to make sure that the product is a high-quality product. Tech lead wants to make sure a high-quality product. Every single developer in QA and everybody else in the team that I might not remember right now wants to make sure that the quality of the product is high. This said, though, if I were to point out one category, one job role that really needs to worry themselves with these responsibilities, is the only job role that actually has in their definition to write software, high-quality software, and those are developers. And this is something that often, I think, gets looked at in different ways. And there are different flavors and compositions of teams, and many of those work in different contexts. But it's not very often that all software engineers in a team feel that their responsibility is to write all the automation, whether there are QAs in a team or not. And this is plain and simply, and again, we're going for a trivial concept, that's why I call them, elephant in the room conversations, is that test code is just code. It builds like regular code, you write it like regular code. It probably should follow also the same rules as all, the best practices that you are accustomed to use in your software. Because test code is just code. So let's try and discuss a little bit more what I've been referring to as a holistic quality approach. So, by holistic, and clearly this is just taken from a dictionary, I refer to, from a philosophy point of view, something that can't be described without all its parts, and where all these parts actually represent the thing. So where multiple components actually are the entity that we're talking about. And I think it's even more interesting when we talk about it from the point of view of medicine. So when we talk about holistic medicine, we look at approaching problem, not only from the disease, let's say, but also from the social, cultural, environmental factor that surround the patient. And that's particularly interesting. And that moves on to this idea that quality is not something that can be just compartmentalized. You can't just, add a new test framework or hire more, STATs or just encourage people and that would work. You need to look at it from all key software development actors and make sure that this approach, this philosophy, this way of working is actually embraced from different perspectives all at once. So these, for me, are the three key factors that impact what I've been referring to as holistic quality. So first of all, architecture. And I'll deep dive into each one of those. So your architecture, your code, and your software practices, and people, which is one of the most underrepresented elements of approach to quality. So I'll deep dive into each of those. So when I talk about architecture, clearly there are a million definitions of architecture. I bet that if I called, in the room and I'll just ask you if you want to share your vision of this, we will get, probably 100 different definitions. For the purpose of this conversation, this is what I'm referring to. So as the set of components and relationships that together deliver services to client. And this is services, it is their deployment, it is the communication between them, and so on. So I've been referring to quality threat modeling as the technique that in time I've been building with teams to try and achieve that vision of how the test strategy should be in systems applied to the architecture. And I'll go through 4 different stages and I'll recap. So some of you might be familiar with the concept of threat modeling. If you're not, threat modeling is a technique used to assess the risks in your systems, in your architecture. And usually you are as a team or some team members, probably aided by a security expert, and they will go through all the potential risk in the system, whether it is in the communication, in the structure and infrastructure and so on, and identify mitigations to be able to reduce the risk on those systems. So it actually looks at surface of risk. So the first step that I usually try and go through is to identify your existing test pyramid. So again, for people who might not be familiar with the concept of test pyramid, is usually a handle to describe the distribution and types of tests that you use in your systems. And the conventional considered best practice is that it looks like a pyramid where the most expensive but also very valuable full end-to-end UI tests are at the top, and then you have multiple types of tests in the middle, and the lower level is usually unit test. So first of all, what I try and do is identify what's the actual situation, meaning what tests do you actually have and how are those named? Because what I found is that everybody says they have unit tests. They tend to have 3-4 different types of tests, and not everybody in the team often is in agreement on what those are. So usually there are umbrella terms that refer to multiple categories, and that doesn't give you a clear view of what in your system is covered and what maybe could even be duplicated, and still it would be cost that you wouldn't want to have. So identify for each of those types of tests how it's meant to be used. Identify how consistently they're used, right? So, for example, often there are some form of integration tests mixed in the unit tests. Sometimes integration tests are what I would call functional tests. In any case, it doesn't matter how they're called. What matters is to have the conversation with the team and that investigation on what tests you actually have, how consistent they are between them, and how many types you have. So you can have a clear view, even plot it if you can. I particularly like visual representation. Of those tests, and create your own pyramid, assuming it looks like a pyramid, might not, often doesn't. So next step is to look at your architecture multidimensionally. So I lay there all the services, all the components, do this with the team, and then map, whether it is communication mechanism, whether it is storage. And I also make sure that I identify whether there are any differences between the infrastructure and the architecture, which sometimes there is, for reasons that could be good or not. And also, I usually try and run a use case, at least, through all the components to address the flow of data and the direction of that communication. So technology applied is often also important, but usually I use it as the last step, because often many things get considered because you go directly to the specific of the technology instead of the relationship of the entity. So let's say, I don't know, a queue between services over thinking of SQS, for example. So the next step is to identify the quality threats and the mitigation plan. Now, what does that mean? So you look at it like you would do your architecture in a threat model, and you try and identify all the surfaces that would require some testing, or in general, all the surfaces, all the relationships, all the communications, all the key business logic information that would be valuable to you in production, which is an interesting exercise because I think very few people would say that, some part of that is not valuable. And then for each of those, you identify what kind of test you would have. So usually I have a conversation about, what kind of test we value, whether in those contexts, whether it makes sense or not. And design, so do some technical analysis on how you would implement those tests, because often they require some support, whether it is data setup, whether it is some mocks, whether it is something a bit more complicated than just your test framework, especially when you look at architecture at scale, or you look at systems that are a little bit more complex than just the insides of your services. And then you build what you would like the pyramid to look like. So based on these decisions that you made on how do you think this should be, you build like this, North Star pyramid. And then clearly this is, again, one of the advice, because I've been in enough teams to know that very few can just drop tools and go and fix all the things they would like to. In my experience, what works really well is to first have this very clear view of where you are and where you want to be, and build some guidelines towards how to get there. So whether it is from now on, when we change a class, then that class will have, that level of testing. Whether it is that area of the system is more sensitive, so maybe we start from there. Whether it is whatever makes sense for your team, having some guidelines on why you would start doing some of that is essential, because otherwise you'll never have the time to do all of it. So usually start with guidelines and make sure that you never regress, so you can only get better. And then clearly you probably want to prioritize the areas that are more sensitive and take it from there. So just to recap, so you identify where you are with, deep attention into the differences in language and expression and how things have evolved in time. You look at your architecture deeply and assess your risk area like you would do for threat modeling. You identify how you think that should be mitigated, so your test strategy pretty much, and you identify what would be the guidelines that will take you from here to there. So let's move to the second section. So the code and software practices. So again, clearly this is a big umbrella term. That means, all the code characteristics and software practices that contribute to overall code quality. And, I don't want to repeat it too many times, but, test code is still code, and hence that's how it should be treated. So again, I will go for my advice that everything that you might want to see working should have tests. And then you probably want to decide how you test your feature at the same time in which you design how your feature should look like. So if you look at your feature as the combination of their tests and the feature itself, you'll end up with a solution that is testable and a sustainable way to go forward. Clearly, if you're a TDDer, that might be a little bit easier because it comes naturally in the process. If you're not, I'm sure that you can do the same anyhow if you're not already doing it. But I think what's really important is that you code, design, whatever phase you usually use in your day-to-day, you do it at the same time. You don't treat tests as second-class citizens. You treat them as a component of the feature you're developing. And then also not underestimate the value of testing features that are not functional. So not necessarily something that your users will see, but they have a strong impact on you. For example, I'm a big fan of testing infrastructure, test performance, test security, test whatever makes sense in your system. But again, the only way I trust that something works is that if I have automation around it. So then there is the 80-20 test code rule. This one is completely empirical and is completely biased by my opinion and my personal experiences. I tell you just, in pure honesty, I don't think I've ever seen any actual research on this. But in my experience, quite consistently, whether it was best code base I've seen or whether it was code bases that we brought to be better to the point of satisfaction, usually the ratio was that 80% of the code base was test code and 20% was production code. And by that, I don't mean test coverage. I mean, let's say roughly lines of code. Because when you look at a feature, it might be that your method has 3 lines, but it might have multiple combinations of how that could be impacted. And then when you look at it at multiple level, there's probably a little more. And if you think of, conventional decoration, whether it's setup, assertions, and so on, the size usually grows. Again, I wouldn't say necessarily to go count your lines of code, but I would suggest this is something I do when I open a new code base. I go and roughly see what's the proportion of test code over production code, just to have an idea. And clearly that is a lot of code to maintain. A lot of code to maintain. And we all know that maintaining code is spending money. And then it's very important to make sure that that code is as manageable, flexible, well-designed as your production code, because you're still going to have to maintain it. So let's go to the next one. So, clearly TDD has many definitions, and also people do it slightly different ways, and even maybe the more conventional ways probably have a couple of definitions. For the purpose of this conversation, I will refer to it as the practice where your feature, test code and production code, is designed based on what your test code suggests your production code to be. And that's hence the picture of the little girl with red hair suggesting the feature to the other, meaning that nothing should be written in your production code that your test code hasn't explicitly asked you to have. And that, for who has a liking for it, tends to bring actually a design that drives you in the direction of support it, of being able to be tested also and change in the future. Now again, these are the 3 rules of TDD from the Clean Code book. Is just to give a reference. There are many, but it might help this way of thinking. So when we look at the first rule, so you may not write production code until you have written a failing unit test. In this case, we mean literally, if you need to test a class, you want to write your test class first and just make sure that you instantiate a class that doesn't exist, that doesn't build. That's your first step. This is the extent of the exercise of the discipline required to be able to practice this to this extent. And then you need to make sure that your unit test doesn't necessarily have, the entire definition of your test, but it just has the bare minimum that you possibly would want to make it pass. And then you start looping that. It becomes particularly interesting when you have features that are a bit more complex and you will have multiple tests for it, and you will have to do this process outside the comfort zone, let's say one test, but over multiple. Now, this leads to the general advice that test code should be treated the same as production code. And that means generally still apply clean code and good design rules, lower duplication where you can, design based on domain. I always try and actually identify a domain of an app by looking at how the distribution of your domain, maybe helper classes in your test are. They need to be performant because nobody runs tests that are slow. And then that's the first reason why even investment in tests doesn't get fully leveraged, is because they're slow. You don't want them to be redundant. You don't want them to be duplicated, because then you don't want that when you change a feature, you have to change 20 million tests. You want to make sure that your tests are pointed and not overlap each other. You want to make sure that they're independent, again, from the same reason, because it's going to be a bigger headache. Invest in greater data setup. Like in all my journeys, nothing has been more significant to the acquisition of a team to, more sophisticated test practices than having good data setup, because once the effort is done, usually it doesn't require that much further investment, and you can add a lot of additional use cases. And make sure that your test code evolves with your software. So the two should evolve together. So your test code and your production code should evolve together. So if there's a shift in domain, there's a shift, whatever form of refactoring you might be doing, the two should go together. Another example of how to leverage the investment that you're doing and also make sure that people use it is to identify quite clearly the different types of tests you have. And based on as soon as you need the feedback loop on those tests, make sure that you place them in the right point of your path to production. Again, for clarity, when I refer to path to production, I refer to the set of actions, whether they're automated or not, that lead your software to production. So you want to make sure that, for example, you have very sophisticated infrastructure tests or security tests that might not help you in the day-to-day of the story that you're writing. Make sure that those at least are in your path to production, so they get run at the right point, but they don't block your development loop. Sorry. Okay, so let's go to the most underrepresented category, in my opinion. So when I look at the team, I look at it as one system. So I look at software as an extension of the human beings that wrote it, and I look at how that software, that code base, will have an impact on the individuals that will work on it. So I try and act on the system as a whole, not only on the specifics of the code base or the individual as a separate thing. And this is because at the end of the day, the people are the ones that build code. So it's quite important when you don't have a system that has the level of automation or in general of quality of the product that you would like it to be, to identify that, why was that the case? Because often software engineers want to do the best job they can. It's a quite noticeable trait in most software engineers to actually have a desire to accomplish and have a certain level of mastering what they do. So when your system doesn't actually do what you expect it to do, you probably want to look at the environment and understand whether they had been motivated to do that, whether that had been considered something valuable for them, whether it was, time pressure. Who said that, the time pressure in that case was an excuse to not have that, and so on and so on. So this is the kind of thing that you might want to look at the environment itself and the individual themselves to identify what's the motivation, because the best test framework around, or the best, course on TDD, hiring a few SDATs, is not going to solve the problem if people are not on board with the fact that you have a problem and that their life could be better if you work slightly differently. So a while ago, I read this very interesting book from Daniel Pink, which is called Drive, which talks about how to, among other things, how to motivate individuals in teams in a professional environment. And what he says is that there are intrinsic motivators that actually create the most performant individual. And those motivators are these three. So it's purpose, autonomy, and mastery. Purpose is the desire of people to do something that is meaningful in their life. Autonomy is a desire to be the master of your own destiny. So make sure that you're not micromanaged, but that you can actually have an impact on what you're doing your own way. And then mastery, which is a very common trait between software engineers, is the desire to actually do a really good job, to be good at the job that you do. And I think that is one of the points that could be leveraged to improve overall the quality of your system. It's important to communicate to all software engineers that software testing is a highly sophisticated engineering practice, which covers, in the best case scenarios, 80% of your code base. Therefore, the mastery that you need to apply to support that, because your tests don't have tests, by the way, is probably even more sophisticated and requires more effort and more attention. So it's about communicating where associating value with the desired outcome and the sophistication of the work that actually needs doing. Which leads us to, again, the famous test code is code, and to make sure that this is, well communicated to people. So I line manage people have done for a bit. I make sure that everybody knows that one of the things I consider as pinnacle of mastery of software engineers is how they approach their tests, among other things, clearly, but it's just a non-negotiable requirement for a software engineer. And also that is recognized, so that make sure that people feel appreciated and rewarded for shifting if that's what was necessary within the context. So just to draw some conclusions, in general, there's no magic pill for good quality. And clearly, I know this is trivial, but some people think that, again, maybe everybody's shifting to TDD. I think TDD is fantastic. Still doesn't solve the problem on its own. That, new test framework or having, a certain amount of time to fix some things might make the difference. In my experience, if the shift, it doesn't happen on multiple levels, it's very difficult to have a significant impact. So when we look at quality, we shouldn't think of tests. We should think of overall the value of the product. And we should look at it more holistically. So look at it as the overall value of what you want to do. So again, these are the 3 key points. So from an architecture, from a pure code perspective and the software practices that you use, and from a people perspective, which is one of the most underestimated aspects in my experience. So these are a few resources. Some of these you probably have come across in your life in the past. Many books have had a contribution in this, conversation that we've just had. I think some of these books in particular have had an impact on these thoughts. So Clean Code, because without Clean Code is a fabulous book if you haven't come across it before, on how to write code that is understandable, good code. Accelerate, one of the best books on software delivery, because at the end of the day, that's what we do. Drive, which I just mentioned, on how to motivate people, what's meaningful to people. Working Effectively with Legacy Code, which is a book that I read maybe a decade ago. And my main takeaway from the book was that you need to cover your legacy code with tests before you want to change anything. And then fantastic Michael Feathers gives us a million different options on how we can do that, but that was my key takeaway at the time. And then there's Ikigai, which is like a Japanese concept which suggests for people happiness and success to identify those intersection areas between various areas of their life that might make them happy. And that, I think, helped me formulate the idea that actually that perfect spot of the level of quality that, won't keep you awake at night lives somewhere in the middle of the key axes of aspects of a team, which for me are the architecture itself, the human beings that work on it, and the quality of the software itself. So with this, I'd be happy to take questions if you have any. Thank you.